Today, Osmania University is organizing National Space Day. In fact, National Space Day is declared by Government of India, and UGC has also given a circular that 23rd August will be celebrated as National Space Day. Because last year on 23rd August 2023, India has made a historic event. It has done a lot of achievement by successful soft landing of Chandrayaan 3 program. In view of this, the Government of India and the UGC, they have asked for celebration of this particular event and spreading the knowledge about the Chandrayaan 3 and space activities. So this program is going on for a week long. And on 23rd August 2024, ISRO at different centers, they are conducting hackathons, guest lectures, seminars, online and offline activities are being conducted. In view of this, Osmania University is organizing this particular National Space Day awareness program and also spreading the knowledge and the kind of facilities ISRO is giving and encouraging the students and faculty and researchers to proceed.
మన భారతదేశం మొత్తానికి గర్వకారణం మన మూన్ సాఫ్ట్ ల్యాండింగ్ ఆఫ్ మూన్. దాన్ని మెమరైజ్ చేసుకుంటూ ఛాలెంజెస్ ఏంటి, ఒకసారి మూన్ మీదకి మనం అడుగుపెట్టాము, పెట్టిన తర్వాత అక్కడ ఉన్న ఛాలెంజెస్ ఏంటి, అక్కడ ఏమేమి మినరల్స్ ఉన్నాయి, ఏమేమి ఎక్స్ట్రాక్ట్ చేసుకోవచ్చు, వీటి స్టడీస్ అన్నీ కూడా జరుగుతున్నాయి. ఇవన్నీ కూడా మన విద్యార్థులకు తెలుసుకోవటం, రీసెర్చ్ స్కాలర్స్ తెలుసుకోవటం వల్ల వాళ్ళు ఆ మార్గంలో రీసెర్చ్ చేయడానికి చాలా ఉపయోగపడతాయి. అలాగే కాకుండా ఇస్రో మన ఈ సైంటిస్ట్ మనతో ఉండటం వల్ల వాళ్ళ యొక్క నెక్స్ట్ ప్లాన్స్ ఏంటి, మనకి ప్రైమ్ మినిస్టర్ గారు చెప్పినట్టుగా నెక్స్ట్ సూర్యయాన్ అని చెప్తున్నారు. సో ఆ ప్రయత్నాలు ఎలా ఉంటాయి ఏంటి, ఇవన్నీ కూడా మన స్టూడెంట్స్కి ఒక మనకి మోటివేషన్ కలిగి రీసెర్చ్ స్కాలర్స్ కూడా ఈ డైరెక్షన్లో వర్క్ చేస్తారనేది చాలా సంతోషంగా ఉంది. ఇంజనీరింగ్ కాలేజ్ ఈ పర్టికులర్ ప్రోగ్రామ్ చేయడం అనేది I feel very happy and proud to be that, and I congratulate Dr. P. Naveen Kumar to take initiative and conducting this event. Thank you all.
Proud to be a part of this, proud to be as a part of the ISRO's community and represent it here as part of the Space Day celebration in Osmania University. I thank the organizers for inviting us, and as the motto for this year's celebration goes, it is touching lives while touching the moon. So it's Space Saga. So we are here to share our experiences or what are we looking forward to in motivating the youngsters to come up into the space arena, because all the space policies have changed and it is all being thrown open for all private sectors and other sectors to join us. So let us hope this is a great event, and there will be a lot of people who will be able to join us and take India to further greater heights. Thank you all.
This National Space Day was announced by our Honorable Prime Minister on 26th of August last year, immediately after the successful soft landing of the Vikram lander on the lunar surface, and the first time by any country on the south side of moon. And this is to inspire the students and the young people of India to take up more challenging work, so that their country will go to greater and greater heights. So National Space Day celebration will help in inspiring such things in the students, and I wish all the very best success for this National Space Day celebration by Osmania University.
And these are the different satellites which we have launched right from the Aryabhatta, which we launched from Soviet Union, and extreme right what you are seeing in the GSAT 11, which is one of the biggest satellite India has made. So you can see the size difference. Actually it's a huge satellite now. So right from 50 kg we have reached some 6500 kg. So these are the different spacecraft we are having. Communication satellites, you all know that they are used for communication. Then Earth observation satellite for observing the Earth and the climate, as well as the crops and other things, agriculture things, and other products from the ground. Then space scientific research satellite like Chandrayaan and other missions, Mars orbiter mission. Then navigation satellite like our GPS systems and all. Then experimental satellite like SRE, I told you already. This SRE module is available in space Trivandrum, our space museum. Then small satellite for specific purposes. Then student satellites like students like you have built. Madam has already mentioned about student satellites. So these are some of the spin-off from space technology, because when we develop technology for the space application, we get some technology which may be useful for the general purpose also. So as you can see, this fuel cell based power generation system, which can be taken to any place where solar power or other powers are not available. Then we have got a fire retardant material. Using that, cloth can be made so that you will not get burnt, and fire operators can use that cloth to rescue the people in case of a fire actually. Then we have artificial limbs. So some of the space technology, we are able to generate artificial limb with a very low weight actually. The problem with the artificial limb is the weight of the limb will be much more than the normal limb actually. So to reduce the limb weight, the space technology is now used, so that this is also one of the spin-off benefit from the space technology. And coming to the space applications, you all know, you are all students, you all know various space application. I don't want to dwell about that more, but one or two things I want to tell is, when I was a student like you, those days I used to hear every year cyclone happening in Vijayawada or somewhere in Visakhapatnam. Every year thousands of people used to die actually, which we read in newspaper as well as in television, or radios also. But these days, same cyclone is happening, but the death toll is 1 or 2 or maximum less than 10 actually. How is it possible actually? It is possible only because of the satellite technology. We are able to predict the cyclone and also the impact of cyclone, when it will come onto the land, where it will hit the land, and how long it will be there, what is the velocity of the wind, what kind of whirlwinds will be there, what kind of calamities it can produce. Everything we can predict in weeks, and so that we are able to take measures to protect the humanity and their dwellings. So that is why we are not hearing such news now. And another thing I want to tell is that the application for the fishermen actually. There is an application for the fishermen. Fishermen are using that application. Using that, they can find out where fish is available every day. So based on that information, they will go to that area on the sea, and they will put their net, and they get lot of fish catch. So after using this application, our Indian fish catch, or the revenue generated from the fishing by our country, has increased by 42,000 crore per year actually. Just by the usage of this system, our annual revenue from fishing has increased by 42,000 crores. Whereas the annual revenue or annual budget allocation for ISRO is only some 35,000 or 36,000 crores. So much more than what ISRO is getting just by one simple application. We are giving it back to the nation actually. And forget about the satellite services. Every communication services, we are freely giving. All the satellites are used by government for various applications of the government. So they are also generating revenue, but I am not counting that. But this alone is sufficient to give back the revenue budget allocation what we are getting. And this is the SRE I told you. This was a module along with the Cartosat in 2017. Cartosat was the main satellite. In 2017, it was launched along with the Cartosat as a piggyback. And after the main satellite was deployed, this was deployed to the orbit, and it went around Earth in some 650 kilometer orbit, and it was 550 kg satellite recovery experiment. And this module orbited the Earth for 10 days. We controlled it. Finally, we deboosted it, and we brought it down to sea actually. Once it landed on the sea, it floated because of this balloon, and our Coast Guard went and recovered this experiment. This is available in the Space Museum in Trivandrum. So when this satellite recovery module was coming back to Earth, it is coming to Earth due to the gravity of the Earth with a tremendous speed. So the temperature outside the nose cone of this SRE was 2000 degrees centigrade. You know that in 2000 degrees centigrade, none of our metals will survive. Copper will melt, aluminum will melt, iron will melt. All the normal materials what we use will melt in 2000 degrees centigrade. Then out of what we have made this? Can anyone guess it? So it is made out of sand actually, normal sand. So it's a silica material, it's a silica tile. Only that tile can withstand such a huge temperature. So now coming to the Chandrayaan 1 mission, I have already mentioned about that mission. So initially when this mission was proposed, only orbiter was there. Only APJ Abdul Kalam told that at least we should put some stone on the lunar surface. Then came the Moon Impact Probe project, and because of that only we were able to find water on Moon actually. So just think, had Abdul Kalam not thought that we should put something on the lunar soil, we would not have found water on Moon actually. Okay, it is that thinking actually. So any small thinking, even if it is very small, sometimes it may reveal to great success actually. Okay, so first of all, what is required is thinking actually. That is the genesis actually. That is the beginning of any success. So thinking is required. That is why I told you in the beginning that you should find some way, at least 1 hour a day for free thinking actually. So you will be able to achieve several success. So in Chandrayaan 1 mission, how did we achieve the Chandrayaan 1 mission? As you can see in this picture actually, we launched this Chandrayaan 1 satellite. Satellite is having Chandrayaan 1 orbiter as well as the moon impact probe. That is a small box actually, almost a 2 feet square box. And this composite was launched into space around some 250 kilometer altitude, and it went around Earth in an elliptical orbit. You can see the first elliptical orbit is that. So after it was orbiting the Earth in an elliptical orbit, there are small rockets in the satellites. These rockets will be fired, and there is a main rocket is called apogee motor that is at the center of that satellite. Then every corner there will be two small rockets. So like that we will have 8 small rockets and 1 big rocket in the satellite itself engine. So this engine will be fired, then we will increase the orbit. So every firing orbit will be increased. It will be elliptical orbit, but the lowest point will be the same point at 250 kilometer, but highest point will be initially 22,000, then 75,000, then 1,65,000, then 2,70,000 like that. It will go up to 4 lakh kilometers. You all know that moon is orbiting around there at a 3,84,000 kilometers away from Earth actually. So in the 5th burn, our satellite was going toward the moon actually, because moon is orbiting at 4 lakh kilometers. So it is actually going around the Earth in an elliptical orbit, but when it reached the orbit of the moon, because of the gravity pull of the moon, the satellite, instead of coming back to Earth, it went around the moon actually. It went around the moon in an elliptical orbit, initially 500 by 5,000 kilometers. Then we fired this apogee motor again. Then we reduced the orbit to 100 by 100 kilometer circular orbit. After it attained the circular orbit, this moon impact probe was separated, and after separation there is no, it simply fall onto the lunar surface. So we had 3 instruments in the moon impact probe: the chase instrument which found water on moon, then the radar altimeter and the video camera. So we operated the instrument 20 minutes before the separation of the MIP. Then it took 22 minutes to reach the lunar surface. So total 42 minutes we could get data. After studying this data only, we could find that there is water on the lunar ambience or atmosphere. So Americans, Russians, everybody has studied, they could not find. It is only because of our instrument, which is a very sensitive instrument, and it is a laboratory instrument. We ruggedized that instrument and flown to find water on moon. We were not having any idea how to find water on moon actually. But when this opportunity came to us, when Abdul Kalam told we should put something on the lunar surface, this MIP idea came. Then we were asked whether you can submit some instrument. So our director proposed this chase instrument. Then he came to me and Srilada and told whether we can develop this instrument. My first answer was, sir, we cannot, because I know that instrument which we were using in the laboratory, that cannot be flown to moon actually. So I told it is not possible. Then he said, if it is not possible, then I will approach somebody else. Then I said, if somebody else can do it, we can also do it. Then he said, okay, then you do it. So it was a struggle for 8 months for us to crack the issue with that instrument. Then finally we were successful and we were able to find water. So when we started that idea, we were not having any idea about how it will be, but we had only confidence with us that we will be able to achieve it. The same thing was told in one of the meeting, because in space technology, we cannot send anything in space unless you know 100% about it. Suppose we want to use a nut or bolt, you should know who has manufactured it, who has purchased it, when it was purchased, what is the cost, what is the material, and where the material was made, which lab it was made, which machinery was used to make that nut, which operator was there behind that making that nut. All these details should be available. Then only you can use any material for space technology, because we should trace back, once something happens, you should trace back what is the root cause actually. Unless you know the entire history of the evolution of all the products used, you will not be able to find where was the fault actually. So that is why unless we know all the details, we cannot use anything in space. But this instrument was developed by some country, and we have to use that instrument for finding water on moon. So naturally we cannot use that instrument. So we have to know everything about that instrument to get an approval to fly that actually. That is the struggle we did to understand the instrument. 8 months we struggled and we understood everything about that instrument and we were able to achieve it. So this is the Chandrayaan 1 mission. As you can see the satellite, and at the top is the small MIP cuboid. And it is a collaborative program. Several countries collaborated. America, Japan, so many countries had their experiment in that. In Chandrayaan 1, American instrument also was there. That was in the orbiter. That also could find water on moon. So I'm not dwelling about this. This is about finding the water. So then comes the Mars mission. So in Mars mission also we know that first time we were the country to successful in the first attempt. To our surprise, it ignited and there was no issue. Everything as planned, it worked. So we assumed that next day after 2 days also it will be firing. Okay, but to our surprise, after 22nd also, 24th also it fired, and we never needed to use the other small engines. So we were able to capture the Mars. So this is how we made the success in the first attempt. So why other people failed is because even in Chandrayaan 1 I told you, moon missions, Russia has failed 5 times, America failed 12 times before they could achieve success. Why? Because when we are going toward the moon, we should not be reaching there before it reaches. We should not be reaching there after it reaches. We should reach exactly when the moon is coming to that place. That is one thing. Second thing is, suppose if we are late, what naturally we will do? We will speed up, no? To reach that, isn't it? But we cannot do that. When we are approaching the moon, the speed of the satellite should be less than the escape velocity of the moon. Otherwise, we will not capture the moon. We will fly away from the moon actually. So if you are late, you cannot speed up. Okay. If you are early, you cannot slow down much, because if it is very slow, you will go and impact on the lunar surface. So the velocity should be exactly the velocity to go around the orbit. So these are the major concerns. Other people have failed, but our mathematical modeling about the engine, our scientific achievements and our simulations and our mathematicians and our engineers could achieve this success because of great minds. This is the Chandrayaan 2. So in Chandrayaan 2, unlike Chandrayaan 1, we have an orbiter, we have a lander, and we have a rover also. So you all know that orbiter was very successful. Then when we are going to the moon, this orbiter and lander is a composite module. So it will go to Mars, go to moon, it will go around the moon, then we separate, orbiter and lander will separate. Lander will take another orbit which is from 100 km to 100 by 330, smaller orbit. Then took the pictures of the land where it has land, then it soft landed. But we reached up to 2 kilometers as planned, but after 2 kilometers it was taking of the engine to take the pictures of the soil where it has land. That after that, when we refired the engine, there was an anomaly and we could not soft land. That is why we missed the Chandrayaan 2 mission. But in Chandrayaan 3, we corrected all these issues. We could land precisely where we decided to land, and it was a soft landing. We were able to successfully land. After landing, this rover came out. You can see that rover panel actually. It just unfurled like this, and through that way it came out, and rover was roaming around. Almost some 60 meters on the lunar surface it is rolled, and it took a lot of measurements. There are some instruments in the rover also. And in the lander also, there are 3 instruments. One of the instruments is the REMLA payload, which we were part of, and we also could operate that instrument. And we are now in the process of publishing papers for that. So this is the Aditya L1 mission. This is the mission to study the sun actually. So there is an L1 point. L1 point is the Gaganyaan point between sun and earth, the straight line between sun and earth. That is the point where the gravitational pull of earth and the sun will be equal. So if you put anything there, it will not go towards earth or not go towards sun. It will remain there as well. So when the earth is moving around the sun, this satellite also will be moving along with the earth around the sun. So it is a very good point to observe the sun actually with less fuel. Okay. But then there is a problem actually. If you put the satellite in the L1 point, you want to communicate with the satellite. No, whatever picture or data the satellite is capturing, you want to communicate to the Earth as well. But when your antenna is pointed toward the satellite, you will be seeing the signals from the sun only, because sun is a huge source of electromagnetics. Okay, so you will not see any signal from the satellite. So there is a problem. So what we did is, instead of putting in the L1 point, we put the satellite in an orbit around the L1 point. Okay. So L1 point is here, but our L1, the L1 satellite will be orbiting around the L1 point. It's called an halo orbit. Then whenever we look towards the satellite, we will not be seeing the sun. So we can get the signal from the sun, but it is still in L1 point. So this is the prestigious Gaganyaan program. This year or early next year, we will be having the first launch. First launch, we will not be putting the human, we will be putting in a humanoid robot. And everything for this test is completed now. So what we did is several tests are conducted. In the first test, there is a crew experiment, that is a crew module experiment. In that, crew module was sent to space of 150 kilometers. Then it was projected to the sea. Then we recovered that. And subsequently, we had a pad abort test. In pad abort test is because humans are involved now. So if anything happens to the launch vehicle on the launch pad, immediately this crew module will be ejected and will go away and safely land somewhere.
A happy moment for all of us, particularly for me, to have been associated with this commemoration of the successful anniversary of successful soft landing of the moon on the moon by the Chandrayaan 3. So I feel a matter of privilege and proud to be a part of these celebrations. And here we have today come as a part, inculcate the awareness, inspire the younger generation, and create interest in the space exploration. And also tell the population about the benefits of space exploration, how it is going to impact the society. It is not just only space. Space satellites, communication, and revolutionary technologies in agriculture, health, discipline, and almost all sciences, and has got a great societal impact. So it is not just space. It is also not only Earth and beyond, but also on Earth itself, many benefits that can do the benefit to the mankind, and particularly to India. This is the moment India is very proud about, and as an Indian, we feel very proud to see that the soft landing of the moon was the greatest achievement. We were the first country to land on the lunar south surface. Though we were the fourth country to enter the space club, but we are the first country to land on the lunar surface of this साउथ रीजन ऑफ द मून।
और बताना ये चाहूँगा मैं, पिछले साल जब ये 23 अगस्त को लैंडिंग का जो सिलसिला चल रहा था, उस समय मैं इनख्वाइस में था, जो अर्ली वार्निंग सुनामी सेंटर है, वहाँ पे कॉन्फ्रेंस में था, और हम लोग उसके एक हिस्ट्री क्रिएट हुई, और उस वक्त में था मैं। तो आई एम फीलिंग दैट एज इफ़ वो एक साल पीछे चले गया, मैं वही मोमेंट मेरे को महसूस हो रहा है। और क्योंकि ये वीक लॉन्ग सेलिब्रेशन हो रहा है, तो आज से शुरू हुआ, 23 तक चलेगा। इसमें यूनिवर्सिटी में बच्चों के लिए कॉम्पिटिशन्स होगा, पेंटिंग कॉम्पिटिशन होंगे, एलिक्यूशन कॉम्पिटिशन होगा। और ये जो स्पेस की जो बात है, इसके लिए हमको रोशनी डालना बहुत ज़रूरी है कि बाकी दुनिया के लोग ये समझते थे कि वो लोग हम एडवांस है, डेवलप हैं, तो समझते थे कि इंडिया को पिछड़े हैं, नहीं कर पाते हैं। मगर पिछले 30 साल में हम लोग साबित कर चुके हैं, और वी आर नन टू अदर्स। हम जो है दुनिया में 2 नंबर पे नहीं है, वी आर 1। और इतने सारे जो एक स्पेस डेब्रीज की बात करें, तो वो जो स्पेस डेब्रीज की भी जो बात हो रही है, बाकी जितने कंट्रीज़ हैं वो लोग जो सैटेलाइट्स लॉन्च करे हैं, वो हमेशा से फेलियर है। हम जब भी करते रहे हैं, शायद 1 बार 2 बार फेल हुआ है, मगर जितने भी हमारे लोग जो एक डेडिकेटेड टीम काम करी है, जिसकी वजह से कभी भी इस फेलियर का नाम आया नहीं है।
Today we are celebrating National Space Day, and our colleague Professor Naveen sir is organizing this event. Really it is giving a lot of awareness among the students what exactly happening in the space. So I am representing the 2 different student forums. One is Institution of Electronics and Telecommunication Engineers, and other one is an Electronics Club. So these 2 club students are doing a lot of activities. So this particular event will help all the students to explore themselves in the area of a space. So definitely this program will benefit all the students. I am again just giving congratulations to the Praveen sir, and also would like to thank all the scientists who have come from the ISRO space to represent and to share their knowledge with our students. So really I am happy to be part of this event. So thank you for giving this opportunity.
They organized a National Space Day. So because due to successful launch of Chandrayaan 3. So the main theme of this organization, this space day, is to bring the awareness among the students. So as a PhD scholar, I already worked on the navigation satellites, GPS and Indian system Navic also. Now this given me more opportunity, and what are the chances and where are the opportunities are there in the other space activities. So this the presentation going on very well. So the Pradeep sir and Srilata madam both given excellent presentation regarding the ISRO activities and ISRO related space research activities regarding the space and Chandrayaan 3 and other research activities, and it given more encouragement to the students who are attended here.
Glad to attend this program today here at Osmania University National Space Day. Scientists from Thiruvananthapuram ISRO has came here and gave excellent presentations. As I am working on navigation systems, the presentation was very fruitful for me. Many doubts have been cleared for me, and I thank Professor Naveen Kumar sir for conducting this kind of events here, and I also congratulate ISRO for successful landing of Chandrayaan 3 last year. So, and I am looking forward to attend more this kind of events here, and I am very thankful for Osmania City and all others. Thank you so much.
Today in our college university, it is a great initiative for the Osmania University to come over the ISRO and also who are the part of the Chandrayaan 3, and talking with them is very gratitude for us, and also learning about the space and also next what are the next plans of the ISRO is very grateful for us. And also for India, we can see that Chandrayaan 3 is India is our first nation to land in the South Pole. So knowing about more about space and also about technologies is very grateful for us, and also collaborating with and this meeting which is more helpful as to learning more about space. And thank you.
I would like to share my experience about today's program. Actually, we thought that it might be not helpful for us, but when we went and listened the total session, we heard first that some scientists from ISRO were coming to share some experience with us. So we went to there, and after listening the session, so many students, as we are studying engineering, but so many students didn't know the hidden facts and all about ISRO and what Chandrayaan 3 satellites, how they will be launched. After listening the session, we understood that.
I'm Pujita from Osmania University. I'm studying engineering in EC department. Today we had a session about ISRO, and we came to know about many facts regarding Chandrayaan 3 and even about our college, and it was very inspirational, and I also found many paths so that I can get into ISRO and lead my career. Thanks.